This is Leetcode problem, the same tree. In this, what you have to do, you have been given two roots of the two binary trees. You are given two binary trees. You have to check whether these two are same or not, identical or not. And what is the definition of identical? Structure is identical. Nodes have the same value. These are the things. So 1, 2, 3, 1, 2, 3 identical. Yes, 1, 2, and 1, 2. Values are same. Structure is different. So false. So it was a pretty simple uh, tree question. That's why it's marked easy. What you have to do, you start from the root, whether the root value is equal or not, right? And else if it is not equal, then you will return 0. Also you have to check first, like you're starting in this as p, this as q. So if p exists and q doesn't exist, you have to return false. Also if q exists but p doesn't exist, return false. This is basically the main checking, if your current node is good, if your p and q, the head pointers, or you can say root, is good, then you have to move for the left part as well as right part and then check if both of them are good, then only you will return true. But this is for checking the root part key, whether the current node is good or not. If one of them is not present there, so you will say, also, if both of them are null, then it is true. Okay, so both of them root nodes are null, you will return true. If any of them is not uh, null and other is null, you'll return false. Otherwise, if a value is not same, you'll return false. Otherwise, you can just say that these are equal, so return this, go on left part and right part and so on. So this is about first problem. You can just try to sum this up. It's an easy problem. Yeah, what should I write in this? Basically, this is the three checking for a root node. If you want, then we can write again. So first of all, you have to check for the current node, then you call on the left part as well as right part. So first of all, the thing is, if your p, if not p and not q, right, if both of them are null, which means both of them are equal and you don't have any p more successor, so you can just return one. Let's say if one of them is not null and other of them is null, or something like which happens key p is not null and q is not null, you will return false in this case, because the value yeah, the structure is even not same, right? So in this case he's checking key, his left is present but his left is null, so that's why he'll return 0. Okay, these are all in, yeah, you can write if or else if, whatever you want. And the next thing is, if data is not equal, p dot data val is not equal to q dot val, and you will return 0. As you can just check on the left part and right part, whatever they return, that's your answer return. Okay, pretty good efficiency. Let's move to GFG problem of the day. This is also tree problem and an easy one again. So let's quickly do this. You have been given a binary tree of size n. Each node have a position positive or negative values. Basically this is a negative value. What you have to do, you have to convert this tree into a sum tree, right? Sum of the values of the node in left and right subtree of the original tree, the value are changed to 0. Okay, so leaf nodes are changed to 0 because there is nothing in the left and right of 8, so the value would be 0. All the leaf node. -2 की value कैसे आ रही होगी? How the -2 is coming as 4? It is doing 8 minus 4. It's not considering this current root node, it's just considering only children part. So 8 minus 4 is 4. 8 minus 4 plus 2 is equal to, let's say there is 8 minus 4, which is 4 minus 2 is 2. And over here it is coming as 7 plus 5. Okay, these are 0. 7 plus 5 is 12. 12 plus 6 is 18. 18 plus 2 is 20. So how I approach this, let me just write again. The first, this is the simple, like, function, because in this you just have to return, your root. So you will do all the manipulations in the second function by creating it as some root, okay, or whatever name you can name it as, solve or some whatever, right? And then what you have to do, this function will do all the work, convert your given tree into the sum tree, and then you don't even need to return, you just are, it's just void function, so it will, it will all do all the changes, and yeah, that's all about it. But the return type is void. I want to use this solve function which have some return type is equal to int. So let's write this solve function. Solve function is doing what? It is calculating, the left part, right part, and then updating the tree. So first of all, if not if, basically, what logic I thought for a particular node. So let's say you are at -2, you want answer from the left part. What is the answer from the left part? Answer of the left part is 0. What is value of the left part? It is 8. What is the answer of the right part? Answer is 0, because in the final tree it will become 0, and I'm doing it post water way, so it has already become 0 0, and currently am I having -2. So -2 will see, okay, left part coming giving me 0, right part giving me 0. So is my answer 0 0? No, basically you will also consider what was the previous left. 8, previous right -4, sum of this. So let me tell you, current answer is equal to previous left plus previous right plus current left plus current right. This is the answer. Current left, current right, 0 0, previous left or previous right is equal to 4 in this case. Now let's take a bigger example. Let's take 10, how 10 is becoming 20. Okay, also for current answer, for current root, for current node, its previous value is not, its previous value is of no use, or like its original value is no use. Why? You can see you are not using -2 anywhere for writing this 4. Okay, it is just sum of subtree, not including the current root. So that's why you have to just see only the children. So that is the two things is no use. And then now we were talking about 20. So 10 is not useful in this 20. Okay, what is useful? You will see what was my answer giving my left part. Left part is giving me answer 4, right part is giving me answer 12. So currently um, current left is 4 and current right is 12, so it is already 16. So I need to see what was my previous left and right. Previous left and right was 6 and -2. 6 plus -2, this was -2, this was 6. If you do sum of all these, it will become 4 plus 16, it will become equal to 20. So that's how the answer is coming. Now let's see how we're doing this. So we are returning something to upper node, my new value, you can say. No, not my new value. He knows my new value because you have changed it, and you can access it by what L is equal to call the solve function on root ka left. This will give him my new value, right? No. This will give him my old value, because that is the thing. Okay, you will understand how I'm getting new value. The current value, for example. What do I mean by new value? Let me just write it. By new value, I mean, like, I am calculating answer for this 10 wala node, which is, currently I'm this point. It is written as 10 over here, but left and right part has been changed to 4 and minus 12, 4 and 12. It's not still the same, like 2 and minus 2 minus 2 and 6. It's now new values. So you already have new values. How you have new values? You'll have, let's say, int new left is equal to nl, is equal to nothing but root ka left cut some data, whatever is present at this data, because you have already changed the left part, you have already changed the right part. Now you are changing the root. Okay, so it's moving backward from bottom to top. Root dot left data I have already have, and new r I already have root of right of data. Now the thing comes over here, what if the root of left is null? So for that matter, you can make a check, and then now what else do you want? Just it is simple, like your root ka data will become previous left previous right plus new left plus new right. Okay, now I have to make some function so that I can return my previous value to this new, what this function is returning. It is returning my previous value, which was initially, which was the initial value of root ka data, and running it to someone who needs it. Who needs it? The parent of root. Parent of root needs the previous value, the original value of root, right? So parent of, let's say, -2, which is 10. 10 needs the -2 value. Why? You can see, like, 4 plus 12 is coming and -2 plus 6 is coming. So I will return the previous data. So it's not root ka data so on, because I have changed the root ka data. It's basically a temp value, previous root data. You can say previous root data, root data, previous root ka data. So in previous root ka data is equal to initially what was the root ka data, yeah, and that is all about it. But the thing comes, like, when it becomes null, what happens if root is not null? You'll return 0. And also you cannot do anything over here if root ka left is null. So let's write it over here, root the left exist, then data, otherwise 0. Similarly, root ka right exist, Then you'll talk about data. Otherwise, zero. That should be fine. Let's try to run this. Root for data is getting changed to this current answer. I have to comment this up. And over here, this function is simple. You don't have to return anything, do anything. You just call this function, which make all the changes by returning something to it. Okay, it's working fine. Let's submit it. Pretty simple question and basic DFS question, tree basic DFS. Okay, successfully submitted. So again, if I have to revise the concept, it is just, how the value for current node is coming. It is coming from previous value of the children's plus the new value of the children's. So instead of L, you can write PL and PR, which is previous value of left and right, which you don't have now because you have already changed the left and right. So how you will have this? You will return this. Okay, you will return this from that left root of left. You will return its previous value by storing it into temporary variable called previous root data, and it will return to its parent, and parent will use these two values and new values that already have, and then parent will return its data to their parent and so on. So this is basically, yeah, backtracking or basically recursive tree question. Okay guys, that's about it. Bye.